Hello, welcome back to the LOOC. In this segment we continue looking at our example of a commission employee and derived classes from it. So first, without using inheritance, we create a new class called base plus commission employee that is an extension of or a refinement of the commission employee class. So this class is a separate class. It has nothing to do with our original commission employee class, although it repeats a lot of its code. And that's exactly the problem, that this class is created by practically copying and pasting code from commission employee and thereby redundantly repeating it. And that shows that creating classes by copy and paste is a bad idea, and we should use inheritance instead. So base plus commission employee that has a commission as well as a base salary will have the same attribute as commission employee, except it also has a private decimal at a property or attribute called base salary per week. As a result, it will have a 6-parameter constructor instead of 5-parameter, because the weekly base salary is also added to the constructor as an input argument there. Sorry about so here. So there's the constructor. Then we have the read-only properties for our first name, last name, and the social security number as before. They are also public properties for gross sales and commission rate as before, with get and set methods, set performing validity check. And then a new property for base salary. So the get method returns the private base salary field or attributes, and the setter modifies it, checking for correctness and throwing an exception if there's an error. It's very similar to the commission employee class. We just added a little bit to it with base salary, and the rest of the code was copied and pasted directly from commission employee. And here is a tester class, which is very similar, except we display a base salary as well. And then we change the base salary only, and we redisplay the employee using the toString method as well as the earnings. And the output will look like that. So an employee called Bob Lewis, who has a total earnings because there's a base salary of 1,000, so earnings per in the first version 4% of 5,000 and a base salary of 300 results in a $500 earnings. But once we modify it for $5,000 gross sales and a base salary of 1,000, makes it more. So it was very similar, mostly identical to the code commission employee, and we copied and pasted to a previous class to reuse its code. So we copied and pasted the code and the possible errors in it by this copy and paste method, and absorbed the properties and method from the original class by copy and paste, which is dangerous. It's better to use inheritance. So if we want to absorb the already written methods and attributes of a class, then we should use inheritance for that. So let's look at the code in this version. So in our version now, we just define a totally independent class called base plus commission employee class, which has now 6 different attributes: first name, last name, social security number, gross sales, commission rate, and base salary. and as a result it has a 6-parameter constructor that sets all these attributes based on the parameters passed in, and then it defines the appropriate public properties for all these attributes, including a new one for base salary right there. So get and set are implemented, and set again performs validity check. The rest of it is copied and pasted from the original commission employee. The earnings are modified a little bit, so it's now commission rate time gross sales as before. There's the commission in parentheses, but the base salary is added so that the sum is the actual earnings, and we again implement an override method of objects toString, in which now 10 different items are actually displayed with all the labels like base salary followed by base salary, and we display them as currency and 2-digit floating point numbers and so on. And the testing program is very similar to the previous commission employee, except we need 6 parameters. When we call the constructor, we have to display the base salary as well when we first display the data of the employees. Then we modify the base salary and redisplay the employee, this time using the toString method by placing employee into a right line, and then the earnings separately. So as before, I'm going to clean the solution so that results of previous rounds are not hanging around, and then rebuild it. So compile it to see if it properly builds, and then Ctrl F5 to run it. And the run results are in the console window that I'm going to move down in the corner. So the employee Bob Lewis is displayed with base salary 300 originally, and then we redisplay Bob using toString. Again, its attributes, including the modified base salary and the earnings that are also that have also changed due to the changes we did to the base salary. So that's our second version of the program, which simply defined a very similar class to one we used before without using any inheritance at all, but a lot of cutting and pasting, which is not a good idea, generally speaking. So next we are going to have to go back here. Next we take a different approach, and instead of declaring a totally unrelated class for base plus commission employee and absorbing the method, so to speak, by cut and or copy and paste, we are going to use inheritance. So we declare a new class base plus commission employee, which relies on the previously created class commission employee by inheritance instead of copy and paste. So as I mentioned before, inheritance in C#, similar to C++, is indicated by a colon between two class names. On the left is the derived class, and on the right is the base class. So base plus commission employee inherits from commission employee. Note also that the word base in base plus commission employee refers to base salary, not base as a concept, as in base class. So base plus commission employee inherits from commission employee or extends it, generally refines it. So since base plus commission employee inherits all the attributes of commission employee, we don't need to redefine any of that. So we don't copy and paste any code, we kind of get them free, and all we have to do is in a derived class definition is adding the new specifics that makes the derived class more specialized than the base class, so the extra smarts, as if it were, need to be added. So in our case it's one new attribute, it's a private decimal base salary, so weekly base salary, and then we have to write a constructor. As mentioned before, constructors are not inherited, so the base class commission employee keeps its own constructor, and when we write a derived class, it needs its own separate constructor. So in this case, base plus commission employee, 6-parameter derived constructor that actually calls the base class as well. So we pass in 6 parameters to the constructor. We pass in 6 parameters to the constructor, of which the first 5 are used by the base class constructor, and we indicate that by a colon and then the base keyword, which is simply a reference to the constructor of the base class, so base, and then in parentheses first class SSN saves rate, which means that the base class constructor will be called there first, and then when that's done, in other words, the computer created a commission employee type object, then we turn it into a base plus commission employee type object by also setting the base salary using the 6th and last parameter passed to the constructor. So base explicitly calls the constructor of the base class, in our case commission employee, and then the body of the constructor simply does the rest, so it deals only with the extra attributes, in this case only one. Note that if we don't put column base and we don't explicitly call a base class constructor, then the compiler will insert a default constructor from the base class which takes no arguments, if there is such a thing. But if there is no argument constructor, then we get an error because there is not a constructor that the compiler can insert. So it's important to keep in mind that when we call the constructor of a derived class, it always implicitly or explicitly calls the base class constructor in every single case, and then this continues upward the class hierarchy recursively all the way to the class object. So if the base class has an even higher level parent base class, then that constructor is called first, and so on. And then the further down we are in the class hierarchy, those constructors finish the details of the previous more general constructors. So another change is in the earnings, and this code actually is not going to compile, and that's why they are red, because we are attempting to return base salary plus and then commission rate times gross sales as before, except those are public attributes of the base class, and this as a derived class does not have access to those. So there is actually an error in that code there, and therefore it will not compile. Similarly, in the toString method, the private attributes of the base class, first name, last name, social security number, and so on, are also indicated in red by the compiler, and if we try to compile, we get errors of them because we don't have access to those private data members. An error is also that when we try to overwrite earnings, then it is not allowed because it was not designated or marked in the base class as a method that can be overridden. In other words, it wasn't marked either virtual or abstract. Those are the two keywords that allow a base method, a base class method to be overridden. And that's another error that this code has. Nevertheless, if we look at the structure that needs to be corrected, there is an easy relationship the constructor with the keyword base involves a base class constructor. The base class constructor has to be called with the appropriate arguments in number and type as the base class constructor requires, otherwise there will be a compile error. Further compile error we would get by not using virtual or abstract, so these are needed. At least one of them, in this case virtual, is the right one, because abstract is used for abstract based classes, but these are not, these are concrete, and therefore the virtual keyword is the appropriate one. It will indicate that a base class method can be overridden in a derived class. The overrider modifier declares that the derived class method overrides a virtual or abstract base class method. And that implicitly makes the derived class method virtual. So if there are further derived classes from the current derived class, they can override this method as well. So if it was virtual at the higher level class, it remains so in every lower level class. And therefore we have to need to declare the earnings method virtual, because if we intend to overwrite it, we have to make that declaration. And trying to access private instance variables or attributes is also an error. And instead we have to use public properties inherited from the class commission employee. So here are the errors that we get because certain private attributes or instance variables are not accessible because of their protection level. So let's look at this second version of the program, our first attempt to use inheritance, even though our first attempt is not entirely correct. So here, oops, that's the original base class, and here is the derived class. So again, commission employee is the base class. We've already seen all the code for that, and there is no change there. And the base plus commission employee derived class now, instead of being written separately and based on a lot of copy and paste, it actually properly utilizes inheritance, or at least tries to do so, but there are some errors that need to be fixed. So again, we need to add only the new additional attributes or instance variable base salary. Our constructor now will have six parameters, and it will also call explicitly the base class constructor. So the base keyword stands for the base class constructor. We see that the base class is commission employee, so when the compiler deals with this, it will substitute the constructor of commission employee in place of base. And since the base class constructor had 5 parameters, 3 strings and 2 decimals, those are passed in. If we don't pass those in the right number and type, we would have an error. And then in addition to that, in the body of the constructor, we have to set the base salary to the parameter we passed into the constructor. due to inheritance, the first 5 attributes or instant variables property definitions will be inherited as well. So we need to define a property with the public set and get methods only to the new instance variable base salary. Again, validity checking is performed, so the value has to be non-negative to be a base salary. And then we try to compute earnings, but to do an override, but that's going to be a problem because in the base class, earnings as a method is if it were not defined as virtual, it would have been a problem, but it's already actually correctly set to virtual, so that compilation would work. However, we still have problems, and hence the underlines, because there are attempts here made to access private methods of the base class. So to see all the errors, maybe I also take out the virtual here. So if we just write the decimal, we keep the original as it was and try to override earnings, then that will be a problem too, as well as the attempt to access all these private instance variables. So let me save all this, and in a build attempt, first clean the solution, and then we attempt to compile this code by rebuilding the solution, and we should get a host of error messages, and here is one right there that if I double click it, that we cannot, so this error indicates that earnings is a problem because we cannot override it without being earnings being declared virtual in the base class. So that's an error right there. So if we want to overcome that, then we have to go back to earnings and actually declare it virtual right there. So that will help, so we can avoid the first error. So if I try to rebuild now, then this error will go away. However, I get a whole host of other errors, and that's due to the fact that I'm trying to access various private attributes such as commission rate is inaccessible due to its protection level. So due to being private, the derived class cannot access those attributes. So let's see how one way to correct this issue. So one is maybe I turned on this version that we try to do here, and close the compiler. So one way of fixing it is using the protected keyword for instance variables or attributes. So we declare the earnings methods virtual, and we declare the base class original attributes protected instead of private. Protected means that derived classes can have access to that, and the compiler will not generate an error. So the changes here that again, base plus commission employee adds its modifications, but without error now, because we redefined the base class methods as protected from private. There is less code repetition and is a generally better implementation at writing an independent class. So here is the testing code with the 6 parameter constructor, and then we displayed the data, modify the base salary, and display the data again using the toString method, leading to the output as shown. So let's look at this version of the code. So here now there is a commission employee base class as shown, but the change now is that all the previously private attributes are now declared protected. So that will allow access to these attributes or these instance variables by a derived class. We also made the earnings virtual to avoid the problem of not being allowed to override it. And then in the derived class, we just have to declare the additional attributes, and can be private because we are not planning to inherit any more from this class. And 6 parameter constructor, and the rest of it is the same as before, except the override now will be successful because we declared earnings virtual, and when we display, when we modify and display attributes, they will work because first name, last name, and so on are no longer private attributes or instance variables of the base class, but protected, and therefore we have access to them. The test program is basically unchanged, so we create a new employee, Bob Lewis, and display field by field or instance variable by instance variable all its instance variables or properties. Then we change the base salary and redisplay the employee Bob Lewis, this time displaying the earnings as well. So this version of the code should now compile, so I'm trying to clean it first. That again sometimes takes a few moments to happen. It succeeded, and now I am ready to rebuild the project. Oops, rebuild solution, and if that completely succeeds, then we can test the application. So it's working on the rebuild, and it succeeded. So we can now test the application. Control F5 to run it without debugging, and here is the output. The base plus commission employee Bob Lewis, its various attributes displayed first one by one, and then we modify the base salary and redisplay Bob, and that's the second set of outputs. Again, we display it in a different format, like the name is Bob Lewis, first and last name on the same line instead of separated by a new line. The rest of it is pretty much the same, except the earnings are up because the base salary is up. So this is a successful implementation of a derived class. Again, it relies on the base class declaring its attributes protected as opposed to private, and its methods that it intends to allow to be overridden, such an earnings being made virtual. You don't have to indicate toString as being virtual because it itself is an override within the base class, because the base class actually implicitly inherits from object, in this case explicitly actually, and therefore, and since toString in object is already virtual, we can override it in the base class and it remains virtual, so that in the derived class toString can be overridden without any further problem. But for earnings, which is our own method that we defined, the base class has to set that to virtual to allow overriding. So this is a successful use of inheritance, resulting in a much more compact code and no cut and paste, as opposed to the case when we defined the base plus commission employee as a separate class independent of an already existing class and just using cut and paste. However, this solution of using private variables is still not necessarily the best possible, and in the next segment we are going to look at how we can utilize inheritance without declaring instance variables protected and keeping them private.